Now, in this video, we are going to take up the introduction to the projections of lines. So, what is a line? A line consisting of set of points. So, we have gone through the projections of points, where we have studied or we have analyzed how the projections of points in the first quadrant will work, the second quadrant, the third quadrant, and the fourth quadrant. Now, when we start with the lines, again, do we need to consider the projections of lines in the first quadrant, second quadrant, third quadrant, and the fourth quadrant? In the first quadrant, if you consider the projections of points, the vertical plane will be above xy line and the horizontal plane will be below xy line. That is, the front view is above xy line and the top view is below xy line. And when you are considering for the second quadrant, both the front view and top view will be above xy line. And when you are considering the third quadrant, the front view will be below xy line and the top view will be above xy line. But in the fourth quadrant, both the front view and top view will be below xy line. This is what we have studied. So when you are considering the second and fourth quadrant, as we see both the front view and top views are above xy line and also the below xy line, so naturally you are going to have a lot of confusions to identify which is the front view and which is the top view, because ultimately what we are interested in the projections of solids. So that becomes a very cumbersome and it is not easy to understand. So that is the reason why we don't use the second and fourth quadrant. But the first and third quadrant, definitely yes, because it is exclusive, because in the first quadrant the front view is above xy line and the top view is below xy line. And similarly in the third quadrant, the top view is above xy line and the front view is below xy line. So, but our syllabus says to study from the first quadrant, so naturally we will go to start with the first quadrant only. So, when you are considering the projections of lines in the first quadrant, so we have the various positions which we need to consider here. The various positions of the lines in the first quadrant is number 1, the line parallel to both HP and VP. Then the line inclined to HP and parallel to VP, the line perpendicular to HP and parallel to VP, and the line, that is the fourth one, the line inclined to VP and parallel to HP, and the fifth one, line perpendicular to VP and parallel to HP. Then the case 6, the line inclined to both HP and VP and parallel to profile plane. And the lastly, the line inclined to all the three planes. So considering these cases, out of which first one we will go to consider the line parallel to both HP and VP. When we are considering the line parallel to both HP and VP, we can see here, that means since we are using the first quadrant, that is VP and HP, so as we see the line is above HP by some distance and the line in front of VP by some distance. As we look from the front view, we can see the distance above HP, and here both the endpoints of the capital A and capital B are equidistant from the horizontal plane. So when you look from the front view, the image will going to fall on the vertical plane, because the front view is perpendicular to, because so this is the front view is perpendicular to, the front view is perpendicular to VP. So this is the way of projections what we do here. So when it goes to that, so image A dash and B dash will going to come here. Similarly, when you look from the top view, you can see the distance in front of VP. So that is from A dash to this capital A. So this is the distance which is in front of VP, and B dash to B, capital B, is the distance which is in front of VP. When it is projected, that will going to fall on the horizontal plane here. So when you do that, so naturally the image which will going to be like this. So here, this case, when you look from here, the image will be like this. Similarly, when you look from the top view, the image which will going to form here will be like this. So this is what we are going to get it from the first position, that is the top view. So this is how you will be able to analyze the distance above HP and also the distance in front of VP. But when the horizontal plane is being rotated by 90 degrees to the bottom side, so that means you are rotating this like this. When you do that, what happens we are going to see. So here, the correspondingly the vertical plane will be above XY line, and this is the XY line, and HP will going to be the below XY line. Correspondingly, the image will also be get rotated such that you can see top view, that is AB, and you can see A dash B dash, which is the front view. Now we need to understand how since it is parallel to both HP and VP. So that means it should be parallel to XY line both in VP and as well as in HP. As we see that when you look from the front view, you can see the distance above HP. So both the endpoints of the capital A and B are equidistant from the horizontal plane. So when it is projected, you will go to get this line here, both A dash and B dash. That is what we have seen here from A dash, B dash. Since both are equidistant from the horizontal plane, so it is the parallel to HP. So once you see the parallel to HP, so that means you are going to see the actual length of the line. Suppose if you have the length of this line as 100 mm, that is capital AB is 100 mm, then the image length is also equal to 100 mm. So that is the reason why it is parallel to HP. Similarly, when you look from the top view, you can see the distance being in front of VP. So when you see that capital AB is above HP by, in front of VP by 30 mm or 50 mm, both the endpoints, which is capital A and capital B, are equidistant from the horizontal, from the vertical plane. So that means here, if capital A is in front of VP by 50 mm, then capital B is also in front of VP by 50 mm. When that is projected here, it will going to fall on the horizontal plane here. So now, since it is both the points are equidistant from the vertical plane, so obviously the line is parallel to VP. So that is the reason why he says line is parallel to both HP and VP. So since it is parallel to VP, where we will go to see that image? The image will go to see on the horizontal plane. That is what we have shown here. The image will go to fall on the horizontal plane. Now we need to consider whether which line is in true length or not. Whether the line is in true length or not. Suppose if you want to decide that capital A and capital, suppose if I want to see the top view line is in true length. True length means what? The true length means it is the actual length of the line. So when you say that the line capital AB is 100 mm, that means your top view should also be having 100 mm length. And also your front view should also have 100 mm. So that is the meaning of the true length. So if I say the capital AB is 100 mm, so then if I want to check whether you have the front view line is in true length, so that means the line has to be parallel to what? Parallel to VP. Then only the line will be a true length in VP. If I see from the top view, the two endpoints of the line are equidistant from the vertical plane. As I see from the top view, the image will going to fall on the horizontal plane. So that is what we have shown here. If I want to check whether the front view is in true length, that means if I want to say that the front view line should be equal to 100 mm, then your top view line should be parallel to VP. You can see both the endpoints of the capital A, both the endpoints of small a and small b are in front of VP by equal distance. So once it is equal distance, then you are going to get small ab, that is the top view. If the top view line is parallel to xy, so I will say this line is x and this line is y. This end is y. If the top view line is parallel to xy, its corresponding front view, that is a dash b dash, what is the top view? Small ab. Its corresponding front view is a dash b dash, is in true length. So that is the reason why we have kept it in capital A and capital B here. Now, that means I am going to repeat, if I want the front view line has to be in true length, then I should check in the top view. If the top view line is parallel to xy, its corresponding front view is in true length. That is what we have seen here. So that is the reason why we have got capital A and capital B. Suppose now, if I want to check whether the top view line is in true length, then where should I look? I should look from the front view. If now what I want the top view line should be in true length. Where should I look? So true length means what? It should be parallel to what? To HP. If it is parallel to HP, then I can see the true length in HP. So that is the condition. If I look from the front view, you can see the distance above HP. Both capital A and capital B are equidistant from the horizontal plane. Since I am looking from the front view, the image falls on VP, A dash B dash. So both A dash and B dash are equidistant from the horizontal plane. So now the line is parallel to XY. Where? In the front view. So since it is parallel to HP, so you are getting the true length in HP. So you can see that you have capital A and capital B in HP. So that is what. In other words, if the front view line is parallel, its corresponding top view will be in true length. Therefore, you have capital A and capital B here. So this is how you can be able to analyze this. When you want to represent this in an orthographic view, you can see that XY, VP and HP. Now you can see that the front view line is parallel, its corresponding top view will be in true length. So in other words, if the two endpoints of the line are above HP by equidistance, then the line is a horizontal line drawn parallel to XY. If the two endpoints of the line is in front of VP by equidistance, then the line is equidistant from the vertical plane, that is in front of VP by same distance. Then you will write this as top view AB. In other words, if I want to have the true length, if I want to check the front view line is in true length, then I have to look in the top view. In the top view, if the line is parallel to XY, its corresponding front view will be A dash B dash is in true length. If that is the reason why we have capital A and capital B here. Similarly, if you want to check whether the top view line is in true length, then I have to look in the front view. If the front view line is parallel, then you can see its corresponding top view is in true length, that is small AB. That is the reason why we have written capital A and capital B. In this case, in both the views, the line will be parallel to both HP and VP. So you will go and get the front view line also, it is parallel to XY. In the top view is also, the line is parallel to XY. So that is what we have told here, the line is parallel to HP, therefore the true length in HP, which is capital A and B. If when front view line is parallel to XY, its corresponding top view will going to be in true length, that is what we have shown here. If the front view line is parallel to XY, its corresponding top view is in true length, that is capital A and capital B. Line is parallel to VP, therefore true length in vertical plane here. So when top view line is parallel to XY, its corresponding front view will be in true length. So this is how we can be able to analyze the line parallel to both HP and VP. Thank you.